So here again, now I obviously skipped line 91, now I hit another one at line 98. So I can add this again to this source line. You can even exclude a whole source file if you feel like you don't want to see it again, or by function or by axis or whatever. So you can keep going like this, and now I get to the next section and go on and on. Then and keep suppressing the detections that you may not want to see anymore. Now, of course, I can't keep running if I say, okay, let me do this one, do a suppression filter from the whole source file. Then at some point I should be, okay, let's suppress this also from the whole source file. Then at some point I should have gotten rid of all the detections, and then it keeps running. But guess what? It's very slow, because it keeps checking access. Each and every memory access gets checked for concurrent accesses, and so this is very slow then. But just wanted to mention this here. So this was just to show what additional options we have here. You have also options to view the task spawn tree and what tasks are actually running, how they are, what is the parent task, and so on. So that you can set all sorts of windows down here to inspect the parallel program. Now, all of this data sharing, specifically these extra windows only work for OpenMP. The data sharing also works for Silk. Data sharing detection and break. Good, so we can make sure if we can modify this while it's running, probably not. We can delete all suppressions, and I can actually switch off the detection and then have it running, and you see it's much faster now. Okay, so basically now what we've done is we got an operating system running, we got an application running and debugging and debugged, so we say we have a system complete. Now the final step would be the performance analysis. Again, for performance analysis actually on the target, as I mentioned this morning, you need the sampling collector, and this needs to be built for the actual target and inserted as a module to the operating system on the target, so it can actually, if you want to do event-based sampling, that is. So if you want to use the hardware counters on the target, you need to have the capability in the operating system, obviously. I don't have it here, and as I said, I wouldn't have had the TCP/IP connection anyway.
That sounds slightly intrusive. I mean, is there a risk that the engineering to collect this data actually affects the way the device behaves, and if you've got timing problems and things like that, that the instrumentation might affect the way in which the various timings interact?
Well, at that stage we're talking about performance tuning, so you're collecting data. I mean, it's no different from what you're doing if you do an analysis on your host if you run a vTune analyzer. It's just that the target systems don't, I mean, on the host, if you install vTune Amplifier XE, this driver gets installed automatically. Since we don't know what OS you have on the target, what flavor of Linux and whatever, this is a manual step. But the mechanism is the same, so you can run the stack sampling without a driver. But if you want to do event-based sampling, that in any case requires the driver.
Okay. But I mean, the sampling itself must be an overhead on the system that you're monitoring, mustn't it?
It's reading. It's just reading counters that are there anyway.
Okay,
so the overhead should be
very
minimal.
small.
Yeah. And not to the effect that it, let's say, that it distorts the result. I mean, if the absolute result is a little higher or a little lower, it doesn't matter.
Yeah.
What matters is how much time do you spend in this or that function.
Okay.
And this, I don't think.
I guess what I was getting at was a performance problem might be caused by either exceptional number of miscache hits or something like that.
Mm-hmm.
And I could imagine the monitoring slowing down one path through the device or through the code more than another, and therefore the situation that gave rise to the functional patterns
Mm-hmm.
didn't arise because you had something that was going a little bit too fast and just basically clearing out the cache. It's now going a bit slower, and then if you're not seeing the problem, the state that caused the performance problem, if that makes sense.
Yeah.
So there must always be a risk, surely, that when you're monitoring a thing, that it might, under some circumstances, affect the behaviour that you're trying to monitor.
I would suggest that we maybe discuss that with Levent afterwards.
Okay.
He is the expert on the performance monitoring.
Okay.
For
more often the other way around, that something which goes wrong when it's running in for real fails to go wrong when you try to debug it.
yeah, that's the other effect, but it's not a good thing either.
Yeah.
Okay, so just to finish up, I mean, you've seen that a number of times here. I actually showed this in the morning as well. If you open, I open a new project here. And then basically this is what you've seen before. If I start a new analysis. Now what you see here is for a regular hotspot analysis, I can set this up. This is what I showed this morning in a slide. If I say get command line, you get the command line here that you can copy to the target. Here, interesting enough, if I go to lightweight hotspots, you see a message here, problem accessing the sampling driver. Now, the reason for this is that this is the V-Tune Amplifier XE from the embedded tool suite, and the embedded tool suite only allows to run event-based sampling on atom targets. And this is not an atom target, that's why it doesn't have the sampling driver installed during installation, but it may only be available on the target if I had done this correctly, you know? So what I cannot set up here is obviously event-based sampling, an analysis that requires the sampling driver, because I don't have it installed here for now. So this is a limit because we want to, we need to differentiate the versions that we have. For example, in the MeeGo tools, we provide V-Tune Amplifier XE for free. But we try to limit it to the use on Atom only. So we try to keep the product separate in their domain so they cannot be used any other. Good. Actually, that's don't want to go any further here. You've seen the live things with amplifier a couple of times a day. So this completes the cycle. Basically, once you identified your possible hotspots here, you go back to the compiler, to your source file, and skip the compile part because that's no different from anything else that you would do in native development. So that's pretty much all I have. Any other questions? Not then. Thank you.